In this video, we're going to talk about variations in mathematics. Now, we already have examples on the screen, so we'll quickly jump into them. For the first set of examples that we're going to be looking into, we're going to be talking about direct variation examples. Anywhere you see this sign, it simply implies proportionality or varies. So this is saying if V varies as R and V is equal to 10 when R is 5. We are told for the first part of it that we find V when R is 2 and you find R when V is 15. Let's find our solution out. So solution, if V varies directly as R and we are told that V is equal to 10 when R is equal to 5. Now, one of the first things we want to do is to convert this proportionality sign into equal to. A way to do that is to introduce a constant. So I'll say introducing constant. I can name my constant anything. It can be C, it can be H, it can be W, it can be B. But for this case, let's say introducing constant K. Okay. To transform this to an equation, I'll now say V is equal to KR. From here, I will first find the value of my constant. I'm told that when V is equal to 10, R is equal to 5. So to find my constant, I'll write for K here. So I'll substitute my values inside this equation. So that means I'll have 10 is equal to K times 5. I clean up the space. This will be 10 is equal to K times 5 is 5K. If I divide those sides by 5, I'll have 5 often divided by 5 here. This cancels out. This K is equal to 10 divided by 5 is 2. So my constant is K. Now this relationship between V and R, the equation is then giving us V is equal to 2R. So this is the equation I'll use to solve for other two things I'm finding. Now for the first question, I'm going to find V when R is equal to 2. So for number 1, for V when R is equal to 2. What I'll simply do here is that since I have my equation ready, I'll simply plug in my 2 inside my equation. So this will be V is equal to 2 times 2. Then V is equal to 2 times 2 is 4. So that V is equal to 4 when R is equal to 2. So I can write it here. Therefore, V is equal to 4 when R is equal to 2. So for my number 2, I'm told to find R when V is equal to 15. Remember, my given equation is V is equal to 2R here. So finding R when V is equal to 15, I'll have V is equal to 2R. I'll substitute my 15 inside this equation so that it becomes 15 is equal to 2R. And then if I divide both sides by 2 to get my R, I'll have divided by 2 here, divided by 2 here. This cancels out this R 15 over 2. 15 over 2 is 7.5. So we can say, therefore, R is equal to 7.5 when V is equal to 15. So let's jump into the second example. And for the second example, we are told that the area of a triangle of a fixed base length varies directly as its perpendicular height. If the area of this triangle is 60 centimeters square, when its height is 10 centimeter, find the first one. We are both find the area when its height is 12 centimeter, then the height when its area is 120 centimeters square. So let's write solution. When given a word problem like this in variation, one of the first things you want to do is to interpret the word problem. The first thing we are told is that the area, you know, that a key term that we're given here is area, and we are assigned as A. The area of the triangle of a fixed base length varies directly as its perpendicular height. Now the two key players here are the area and the height. So what it says is that the area of a triangle of a fixed base length varies directly. That means to interpret this, we write this as A. Now remember, this symbol can be interpreted as varies or proportional to. Okay, so we write it as varies. A varies directly as its perpendicular height. Now, like we did before, the next thing we want to do is to transform this statement into an equation. To do that, we have to introduce a constant. So we say introducing constant k. So if we introduce a constant k, introduce it to the right hand side of our equation, then we get A is equal to KH. So what is the information we are given about H and A that can help us get our constant? We are told that if the area of the triangle is 60 centimeters square, when its height is 10 centimeters. So we are going to use this information here and here to get our constant k first. For k, we know that A is 60 centimeters square when h is 10 centimeters. So we simply plug all these things inside our equation here to get our value of the k. So that means we have 60 is equal to k times 10. For me, I have 60 is equal to k times 10 is 10k. So that from here, I can divide both sides by 10 to get my value of k. So I'll say divided by 10 here, divided by 10 here. This cancels out this. And then k is equal to 6. As k is equal to 6, that will tell us that A is equal to 6h. For this first one that we are told to find area when the height is 12 centimeters, we'll come here and say for A, when h is equal to 2. So we'll pull out the formula, which is A is equal to 6h. And plug in our value of 12. So we have 6 times 12. So the area is equal to 6 times 12 is 72. Remember, area has a unit of centimeter square. So put the unit here, 72 centimeter square. For the second one, we are told to find the height when its area is 120 centimeter. For h, when A is equal to 120 centimeter square. The formula we have on our hands is A is equal to 6h. So if you plug in 120 centimeter into this formula, you have 120 is equal to 6h. If we simplify this and divide both sides by 6, this cancels out this. This will imply that h is equal to 120 divided by 6 is 20. Now the unit of height from the question is simply centimeter. So we write 20 centimeter. So that's it on direct variation. Let's look into examples on inverse variation. So like we did before, we take the examples one by one. In this case, we are told that if y varies inversely as x and y is equal to 4 when x is equal to 2, let's find x when y is equal to 2 and find y when x is equal to 3. I'll write out solution here. The key proportionality we are given is that y varies inversely as x. And they were told that when y is equal to 4, x is equal to 2. Like we did before, one of the first things we do is to transform the proportionality we are seeing or the variation we are seeing into an equation. We do that by introducing a constant. So introducing a constant here, we say introducing constant k. This will become y is equal to k over x. Now that we have an equation, we try to find the value of k. How do we find the value of k? We use these two values that we're given from the question. So that if we substitute these values into this equation, it becomes 4 is equal to k over 2. So from here, if we had to find the value of k, we cross multiply. You have k is equal to 4 times 2. From here, k will be equal to 4 times 2 is 8. Now that we have the value of k, the new relationship would look like y is equal to 8 over x. So this is the relationship we use to solve our questions. For the first question, we are told that find x when y is 5. So for x, when y is equal to 5. If you plug the values into this equation here, the equation is y is equal to 8 over x. So if you plug the value of y is equal to 5 and make x a vector formula here, you have 5 is equal to 8 over x. If I cross multiply here, I have 5 times x is equal to 8. 5 times x is 5x is equal to 8. Dividing both sides by 5, cancelling out, and then I have x is equal to 8 over 5. So that's the value of x when y is equal to pi. Now for the second example, we are told to find y when x is equal to 3. When x is equal to 3. The equation we have is y is equal to 8 over x. When x is equal to 3, you simply say y is equal to 8 over, we plug in 3 here, so there's 8 over 3. So that's the answer for this one. Let's look into the second example. For the second example, we have a word problem, and we are told that the radius r of a cylinder or a fixed volume varies inversely as the square root of its height. This is important, the square root of its height. If the height is 10 centimeter when the radius is 5.64 centimeter, find the radius if the height is 12 centimeter. The first thing we want to do is to find the key things we are using here. The first thing we are having here is the radius. The radius is playing a key part, and we are terming it as r. Another thing we are having here is the square root of the height. So square root of the height. And we're told that the radius of a cylinder of fixed volume varies inversely as the square root of its height. So we'll write it as r is inversely, that means we have 1 over the square root of heights. Now that we have this, the first thing we want to do is convert it to an equation and introduce our constant. So introducing our constant k, we have r is equal to k over square root of h. Now the first thing we want to do is to find our constant k. If the height is 10 centimeter, the radius is 5.64 centimeter. So for constant k, we have values to help us find it. That those two values are h is equal to 10 centimeter and r is equal to 5.64 centimeter. So then if I plug them into this equation here, it becomes r, which is 5.64, is equal to k over square root of 10. I cross multiply from here, I have k is equal to 5.64 times square root of 10. K is equal to 5.64 times square root of 10 is 3.162278. So if you multiply these two values together, you get around k is equal to 17.84. So we use this value for k to 2 decimal places. Since the value of k is 17.84, our equation becomes r is equal to 17.84 divided by square root of h. Now, from our question, we're actually told to find the radius if the height is 12 centimeters. So the key thing we're looking for is the radius if the height is 12 centimeters. So I'll say for radius, if h is equal to 12 centimeters, and I'll bring in this formula. So this formula is simply r is equal to 17.84 divided by square root of, I plug in my 12. So if I use a calculator and punch this in, I'll get 5.15 to 2 decimal places. Now remember, r is in centimeters, but this can be written as centimeters.